My name is Kanagaratnam. I am the head of manufacturing engineering for Chelton. Today we are going to talk about robotic automation in aerospace and defense industry. That's a very good question. So most of the aerospace and defense systems, when they were designed many years ago, it was never designed for automation purpose because they were smaller batches, complex processes. Due to the nature of that, it was never designed for automation. So the way we have done that by analyzing all the deviation in our manufacturing methods and also the deviation in components and putting controls within the robotic automation system. So the sensor technologies, the vision systems will measure and control all the deviation in our processes. Also, we are introducing Pocoyoco style introduction for all our components coming in. That will eliminate any deviation in our processes. And we design and develop this robotic system in modular fashion. And also, if you look at this, it's a 6-axis robotic system, which is a flexible automation. So we can change and modify and redo the programs a lot more easier in terms of our automation technology. So one of the key learning curve for us is to involve people from operations, especially the operators, the people who test these systems, with their knowledge. So whenever we design and develop our automation system, we involve the people who actually did the job. So they know what works and they know some of the issues with the designs, some of the issues with the processes. And they actually have taught us a lot of lessons and we learned a lot from them. And when we design and build the system, they were involved with that from day one. Also, we look at the previous history in terms of scraps, rework, in terms of its design issues, all the key controls, variabilities. Then we go into a modularized design and iron out some of those issues and make the system a very robust, repeatable, automated system. So the success comes from the phase after this. So this is our manufacturing build sequence. After we build this system goes into a testing, and we are looking at the test data, how we have improved. So we know the past yields from some of these platforms. Currently, some of these products are giving us 100% yield. Also, we identify some of the kind of critical characteristics where some of the failure modes are, and using vision system, sensor technologies, we can keep all our CPKs into the narrow bandwidth where the process has to be centered in that region, and we get a very repeatable, accurate process. And as I said earlier, we can always adapt and change as this is a flexible automation system, so we get a very consistent product all the time. Again, that's a great question. So everything we are doing is to get a zero defect culture. So all of our automations, the key philosophy is to get a zero defect, repeatable process. So from a customer's point of view, this will actually reduce the cycle times. So we can produce our systems a lot more faster, plus a very accurate, reliable, consistent product. Also, we are getting data as well. So there's a traceability element using the robotic system. So if you do certain things, for example, if you solder manually, you don't know what temperature that particular component was applied. Now with our vision data, with the sensor data, we can capture a lot more data with each system what we are building. So you got a lot of traceability there as well. So it's repeatable, it's consistent, and also it's traceable. So from a customer's point of view, this will be a very high quality products we will start to produce going forward. So this is only one platform. We will start to produce more and more of these automation platforms. For Chelton, the lesson learned from this particular system, we can now apply that onto the next platform. Also, we will incorporate automation method of manufacturing in our future NPIs. So we will get involved at the design phase. So we will work with the designers and our engineering team to implement design for automation at an earlier phase so that the transition will be a lot more smoother and we can iron out some of the consistency and get a more repeatable, consistent product.